I'd like to show you give you a tour of an Excel file that I created that is a Steam Tables tool. I'm going to try to set this video up for about 30 minutes of material, but it's my hope that if you're interested in learning more about this Excel file that I offer to you, it may save you hours and hours of interpolation in homework problems and perhaps problem solving, thermal systems problem solving, if you're a new engineer or a young engineer. So let's go ahead and get started. So I call this Excel file my Steam Tables tool. And of course, remember that this particular Steam Tables tool is going to apply to the substance H2O that's going to be existing in certain phases that you're familiar with now, right? It could be saturated liquid. It could be a saturated vapor. Could be a mixture of liquid and vapor. Could be superheated vapor. Or in fact, things like tap water, shower water, lake water, those would be considered compressed liquids. And in many of your engineering situations and or homework problems, you need to find properties of that substance H2O. And so here's the objective of what I hope is going to be about a 30-minute tour of this Steam Tables tool. I want to show you how to download the Excel file. I want to give you a little test drive demonstration of how you can use the Excel file as a standalone tool, and even perhaps use it, and I'm going to drop down here, use it as a problem-solving tool with engineering problems and homework problems. And I'm going to remind you a couple of things that you really need to already have understood. You already covered, feel like you're pretty comfortable with these two concepts. What is the phase of a substance like H2O? And what is the state of a substance? So I'm going to cover that too, just to be absolutely sure you're familiar with or comfortable with what's a phase and what's a state. Okay, I'm not ready to go live yet, so I'm going to show you some screenshots first, and then I'm going to try to show you sort of a live demonstration. How will you download this Excel file? You'll go to Jay's Toolbox website, click on Toolbox, drop down the next menu to XLS, Excel Documents, and I've posted lots of Excel files out there that you're welcome to download, and this particular tool will be under the XLS Steam Tables category. You'll click on that and you'll be able to fish through and find this particular file called Steam Tables. My source data is from the Moran and Shapiro textbook. You click on download and you'll be able to possess this file. Now, this is going to be a screenshot of the very first tab of this multi-tab, multi-worksheet Excel file. And I've got it sort of arranged in terms of an index so that any user, including myself, can stay organized with both units, English and SI. Recall that our Steam tables are divided into English and SI units. And each of these blue cells are hyperlinks. And so when you click on any of these blue hyperlinks, that will jump you within the file to that appropriate worksheet, what I call tab. Now, these top three categories are purely data tables. There's no mathematics in any of these 6 worksheets. The next category is my Excel tool that I created out of thin air. And that's the tool, that's the Excel tool that will go and look up for you various properties depending on the phase that you specify. So it's a lookup and interpolation scheme. These 4 worksheets are working tools in Excel. Then finally, I've got a little tab that's some graphics, And I've created a little bit of a learning tool for those of you that still need a little help in entering some numbers and helping you understand, well, what's the phase? What's the phase of this H2O substance? I've got a little learning tool that you may wish to give a try, take out for a little test drive and see if that might help you with your understanding. And then we are getting there to do the live demo. You have to trust me, but I want to point out an important reminder about my personal work. When you see Excel cells that are colored yellow, that have a yellow background, that means that the user, like you or me, that's where we fat finger in, we manually enter a number, a value in that cell. So that's what a yellow cell is all about. Now, white cells, or in other words, uncolored cells in my work, those are going to be formulas. They may be simple formulas, they may be complex formulas, but in any way, you're free to possess this Excel file. Don't modify those files, those cells. Don't modify those cells because that can be the kiss of death, and you really don't understand what's going on unless you really, really understand what's behind the Excel formulas, and then you can edit those. All right, this is a little screenshot of all the tabs that I have within the Excel file, and do recognize that there are inter-tab links between various tabs. So for example, let's see, property lookups English, for example, that particular tab has formulas in them that go out and grab data from another tab. That's an inter-tab link. So do be aware that these tabs don't necessarily stand alone. Okay, so with those introductory remarks and screenshots, I'm ready to go live, and so I'm going to do the best I can to give you sort of a live off-the-cuff tour of this Excel file, and I'm going to try to use this slide. I've got it printed out, and I'm going to try to use it as a crutch for myself to prompt myself on what I need to do. So let's see. I'm going to escape out of PowerPoint, I hope. I am. Minimize that. I'm going to go to Excel, and I have downloaded my Excel file already. So here we are in this Excel file. So notice here, it's called Steam Tables, Moran and Shapiro.xls. That's the file name. Notice here that we're at the leftmost worksheet tab called Intro. Okay. And this is nothing but text. These things here that I'm clicking on, nothing but text. But these blue and purple cells are hyperlinks. And so we'll go to that in a second. I'm trying to prompt myself on what do we have. Here's my reminder to you about a yellow cell is a manual numerical entry that you enter a number. White cell, leave those alone. And let's look down here at the bottom of the Excel file. Lots and lots of tabs. In fact, there are so many tabs that I have to keep clicking, go to the right to show you the rest of the tabs. So I try to name my tabs and give you clues on what the content of the tabs is. See, for example, here's the learning tool. Here's a property lookups in SI units. Here would be the SI temperature table for saturated conditions of H2O. Here would be the pressure table, and on and on. Let me click to the right. And you see how these tabs go on and on. So for example, here, the trailing tab, superheat lookup English units. So this is where you would enter a pair of data, and the tool will look up the rest of the properties for you. And this last tab is just some graphics, a demonstration of how to use graphics in Excel. So let's go back to the index. I'm going to check my cheat sheet. Got it. Overall file organization. There you are. Let's continue on. Let's look at these rows. It says saturated properties, temperature tables. It's going to be it's copied and pasted values right out of the textbook. I just went to Adobe Acrobat. I copied the table values. I checked my work. So let's see what we have. Let's click on SI, saturation properties. Look how similar this table of numbers looks to the textbook. Okay, notice the column headings. They're similar. I've tried to replicate those. I have frozen my rows, and as I scroll down, the column headings are frozen in Excel, but all I've done here is copy and pasted values. I've tried to format the numbers to make them look sort of pretty, okay? But you see here, for a temperature table, the left column is the saturation temperature, in other words, the boiling point temperature. The next column, well, it's not bars. In SI, I'm always working in KPA. So my units are KPA. This would be the pressure that corresponds to the boiling point temperature. Okay, well, let's look at what do we know? We know 100 degrees C. We know that 100 degrees C is the boiling point at 1 atmosphere. There you go. That makes sense. And then here are all the other properties associated with the vapor dome: specific volume, internal energy, enthalpy, and entropy that you may be familiar with or you're getting ready to learn in a few weeks. Okay, so there's the temperature table. Let's go back to the intro. I'm going to click here, go back to the intro. We're going to go a little faster, but I'm going to click on the English. Look at this. So again, back to the temperature table, except in English units. You can notice that I've very similar copy and paste, except my units are clearly shown. Let's go back to the index, intro, okay? The next is, just for completeness, I've copied and pasted the pressure, H2O steam pressure table out of the textbook. There it is, and that's going to be in SI, pressure SI. I've done the same for English. You can figure that out. Let's look at superheated vapor properties. How did I handle that? Remember, in your book, there's lots and lots of subtables that are based on pressure. Let me show you how I did that. I'm going to click on the SI version of my superheated vapor tables phase, superheated vapor, H2O. Here's my column headings. And if you compare this to the textbook, you say, look at these columns for each pressure. I've got a temperature, volume, specific volume, internal energy, enthalpy, and entropy numerical entries. And in order to make the tool work that I've designed for myself, I created this file for myself to use, and and others are welcome to use it. Okay. Notice here, I've stacked each of the little subtables I've stacked them row by row by row and tried to organize them so they're visually appealing. So here's so for example, 500 kPa, that would be like 5 atmospheres. I'm going to light this up. So there's our little subtable of 500 kPa. And so this, again, is a copy and paste version of what's logged right out of the textbook in the Adobe Acrobat mode. All right. And so I hope and why did I do it this way? And that's so that the mathematics and the Excel searching function will work out nicely in order to evaluate properties. Let's say somewhere, well, let's continue looking. Let's say our pressure, we have superheated vapor phase, and our pressure is 650 kPa. You see that I have to do some searching in between 500 kPa and 700 kPa and do some interpolation to determine my properties, V, U, H, and S. All right, so we've worked through the given data. Now let's look at this lookup tool. What does that mean? Lookup tool for saturation properties. That means that you have a situation where, let's say let me click on it. Okay. This is a formula. Okay, so it's a number of formulas. Let's say you have the temperature of your problem, your H2O, and you know that it's under the dome. It's a mixture, okay? And so you need to determine, all you have is the temperature. And you might say, well, it's a mixture, but you need to determine the pressure. 205 is not tabulated in our temperature table in the book. So what I've done is, so these are formulas. Let me click over here. Now, let's look at the organization. First thing I'm doing is looking at rows 3 through 5. 3 through 5, if you have the temperature. I've turned that cell yellow. That means I'm fat fingering in the number 205. And look what's returned, 1730. The pressure at which water boils at 205 degrees C is 1730 kPa. Here's V sub F. Here's V sub G. U sub F, U sub G. So you see what's going on. Think of a PV diagram. I'm entering one number, temperature, and I'm looking up in an Excel table and I'm interpolating in between, let's say 200 and 220 or whatever those numbers are. And to give you, I don't want to dissect and show you, here's exactly the way I do it, but over here in the right, okay, these are Excel formulas. I'm looking for a match row over in my temperature table, I'm looking for a match row for A5, for the number 205, and I'm looking for that match, the best match, in the A column of the temperature SI tab. Okay, that may be Greek to you, and that's okay. You don't have to fully understand what's going on, but do recognize what you can do is if you have the temperature, now let's say it's not 205, let's say the temperature is 226. Enter 226. Of course, you can go to your textbook. You should be able to do that because you're not going to have this tool available in a quiz or a test, are you? So you have to be sure you can do this work on your own from a paper table. But once you've mastered that, you can use this tool. Enter 226, and all of a sudden, boom, what's returned is saturation pressure, 2604 kPa. Here's V sub F. Here's V sub G, and on with internal energy, F and G, enthalpy, F and G, and entropy. So that's the nature of this tool. Property lookups in SI. Now you say, wait a minute, okay, that's great. I can use that. But there have been some problems where I knew the pressure and I did not know the temperature. In the next rows, I've created the next little tool associated with the vapor dome. So you're either a saturated liquid, or you're a saturated mixture, or you're a saturated vapor, okay? And if you know the pressure, these 3 rows is the tool where you fat finger in your pressure. In this example, I've used 206 kPa, and immediately all this Excel work over here goes and finds the match row. It does turn out in the temperature table. Of course, if you were solving this with your paper book, you'd go to the pressure table, but the pressure and temperature tables are identical numerically to each other. So I go in, I enter 206, and here's the return. The boiling point temperature is 121.05. And similarly, here are all the F and G saturation properties. So that's the nature of the tool, property lookup SI. Let's go back to intro. Here's what we were just looking at. And so do recognize it says lookup tool for saturation properties. In other words, you're looking for properties associated with the vapor dome. That's where you're either a saturated liquid, a saturated vapor, or a saturated mixture, okay? What's the next more complicated lookup situation? That's where you are a superheated vapor. And the mathematics is more complex. You've gotten the experience of interpolation in the superheated tables. Wow, that can be tough. Let me show you the tool that I've created. I created it for myself. welcome for others to use it. Let's look at the SI version. Okay. Here's what we do here. So typically, so on the screenshot, here's an example. It is a big block of Excel calculations and things. Let me show you what a big block of calculations this is. It goes all the way down to here. So it's like 52 rows, okay? But because it's complex, when you have any pressure, okay, well, there's 100 kPa. You'd be able to look that up, okay? And let's say 200 degrees C. If you had that, you don't need this tool. You can go right to your book. You can go to a pressure of 100 kPa. That's about 1 atmosphere. And 200 degrees C, that's well over the boiling point of 100 C, okay? And so you could just look up a number in your steam tables. And in fact, here it is. I fished it out of my table. Here's the 100 kPa table. And at 200 degrees C, you could just look up these numbers. And so notice these blue cells. That's a replication of those looked up numbers. That's easy, isn't it? Well, what if your pressure is 115 kPa? And your temperature is not 200, it's 203. Now, that's common for engineering practice. Very unusual for us to have numbers that exactly match our steam tables. So 115, 2, how would you do this on paper? Well, you'd look at your pressure, say 115. I've got to look through my book. Oh, and I see that I'm going to have to come up with some number between 100 kPa and 150 kPa. I'll need to interpolate. That's what this Excel tool does. It goes off and gets both of the tables from my superheated SI worksheet, okay? And then it goes, okay, well, I need a temperature of 203. Uh-oh. Let's see here. Over here in 100, I've got 200 and 240, but I'm 203. And over here, here's 200 and 240, but I'm 203. I've got to interpolate again. And that's what this next set of Excel calculations does, is interpolates for the temperature. It does all the math. And again, I'm not going to show you how I dissect and created all of these little Excel formulas. I'll be happy to do so offline, be happy to work with any of you who want to work about how did you do this? It was not that hard, but it did take some Excel experience. Not that hard. And I'll be happy to work with you and show you how I did it. But here's the numerical result. In these blue cells, for me, those are transferred bottom line cells. So notice here, I'm going to click on this cell E5. So notice it's a very simple, it's the number 1.96625, but it's an extraordinary simple formula. It is E52. So whatever E52 is, here's E52. Well, this is where the Excel formulas get complex. So in my work, I learned to keep things simple and do one thing at a time in Excel, because rows and columns are very cheap, okay, very inexpensive. And so I do things one thing at a time, and this is how I come up with this very simple formula in Excel equals E52. So it is not a complex formula, but certainly I would claim that there are complexities to doing a double interpolation for superheated vapor with strange pressures and temperatures. Okay, I hope that shows you what you need to do for P&T given in superheated vapor. I'm going to scroll down in this worksheet. Let me scroll down. Now I've got something similar for you. You may not have gotten to this in your class yet, but there will be times where you're not given pressure and temperature and you know you have a superheated vapor. There can be times where you're given pressure and the property entropy, S. Very common that we engineers are given pressure and entropy, and we have to figure out the other properties. Well, I've done the same setup for these two known values. Notice how they're yellow, okay? I do the math and return those properties, okay? And so, for example, well, again, 193, it's way off. Well, let's say it's 293 or 295, and S happens to be 7.41. Very strange numbers. Okay, it goes off and it finds, okay, what Excel does in formulas that I've created for you, it says I'm in between 150 kPa, 300 kPa, yep, 295. So I'm going to be pretty close to 300 kPa. And I've got an entropy value of 7.4. And so it looks like I'm somewhere between here, 7.41, and here. And Excel, I've created the formulas in Excel down here that do that interpolation for me and for you. It does it over and over again automatically. I'm going to keep scrolling because another very common real-world engineering problem is you have a superheated vapor and you have the pressure and enthalpy H known. And you see the repetition. Okay, here's where I put in my pressure and my enthalpy H, and it goes and it does the double interpolation for you again. And so that's what I prepared for you. Let's see, where were we? We were on the superheat lookup SI tab. So SI units, superheated vapor phase. Okay. And remember, yellow cells, you enter the numerical numbers there and you get the return of these numbers. And if you do it the book way with pencil and paper, with paper tables, you're going to get the same numerical results over and over and over again. So let's go back to intro. Okay, so here we are back to intro. We were just looking at this tool here, lookup tool. Okay, and what I've tried to do, let me check my cheat sheet. Standalone features. What I was just showing you there was standalone features. If you know you have a saturated vapor, saturated mixture, saturated liquid, you can use this lookup tool for saturation properties. And what good does it do you? If you know the temperature, you would use sort of this block right here to get your properties. If you know the pressure, you kind of use this block right here to enter your pressure and get the other properties. And in fact, I've added another one for this. This is commonly used in power plant analysis where you have H sub F and you need to look up the temperature. And so this is another common real world tool where you have H sub F, the enthalpy of the saturated liquid, and you have to figure out what temperature the H2O, the hot water, is at. So that's another common one. But you get the idea. It can be a standalone tool. This can be used as a standalone tool for looking up steam table properties. Okay, now looking ahead. So I'm checking and look at my cheat sheet to let you know some things. Looking ahead in the next video, I want to show you how to use this Steam Tables tool, use the Save As feature and build in the lookup tools as you need to solve a thermal systems problem. Let's say a pump analysis or a boiler analysis or a condenser analysis or a steam turbine analysis. So rather than simply using this as a standalone tool, I'm going to show you in the next video how to use this as a tool that you could integrate into an Excel problem-solving tool for thermal systems problems. And I'll tell you that I did this over and over again, hundreds and hundreds of times in my manufacturing engineering role as an engineer and then as a supervisor helping other young engineers solve their problems as well. Got a lot of mileage out of this. Okay, so looking ahead, I'm going to show you how to do that and a pitfall. Let's see. Let me go back to PowerPoint. Okay. I think I've gotten back to, let's go back to the intro. You're welcome to look at this, explore this. One last thing before we go back to PowerPoint. Let me click on the learning tool, phase determination learning tool. This is one that I've created for folks, including myself when I was doing the homework in classes. It helps you learn what are the phases of H2O. Here's how you use it. Remember yellow cells, fat-fingered entries. On this text, if you click on this, notice how I've created a drop-down box. This is all done in Excel. What you do is you drop down, and I've made it a selection. On the first entry, you select either a pressure or a temperature. So I'm going to select pressure, and I'm going to fat finger in a number, let's say the pressure of 110 kPa, okay, and a temperature. And so here you've got a pick list of lots of properties you could select, and I'm going to select temperature and 20. Let's see, what's at a pressure of 110 and temperature 25 degrees C. What does your common sense tell you that is? That's a lot like hot tap water, isn't it? A pressure of 110 kPa, or even warm tap water. So that should be a compressed liquid. And anyway, the learning tool, it goes and it looks up the saturation properties at that pressure, and it does the logic. The Excel does the logic for you to say, oh, the phase of this substance is a compressed liquid. The temperature is below the boiling point. And so that's the answer. But let's increase our temperature for 100. Let's go above the boiling point, 175. Wow. If our temperature is 175 and our pressure is 110, well, we go and we look up those same properties and we say, oh yeah, okay, the temperature is above the saturation temperature of 102 degrees C, so therefore our phase is superheated vapor. So this is just sort of a courtesy. It's a learning tool that I hope might help you in learning how to quickly determine the phases of H2O. So, okay, so anyway, there's a learning tool for you to explore. I hope it might help you. All right, I don't want to stop sharing, but I want to get out of Excel and get back into PowerPoint. Okay, so I'm back in PowerPoint. Okay, there we go. I tried my best to give you an overall view of that Excel file that you can download. You can possess it. It doesn't cost you a dime. Recognize it. And I started from a blank slate. I started that Excel file from a blank slate, and am delighted to share it with you. But I use it myself. I continue to use it, and I used it a lot in industry as well. Okay, worksheet detail. Oh, right, I'm glad I put this slide in. These two tabs entitled pressure SI, these two pressure tables, they are not used in the lookup of the vapor dome properties. I've only included those as courtesies for completeness of copying and pasting the textbook tables into an Excel file. So this is a courtesy for your own manual lookup work, or however you might want to use this Excel file. Some people say, okay, so that takes care of that. Okay, some folks may say, I don't want to use Excel. I've heard a lot of things that Excel is not useful, or it's beneath me to use Excel. I would tend to argue with that, however, but that's okay. If you choose not to use Excel, remember that at least this Excel file can give you the copy and paste ability of all those steam property thermodynamic tables to copy into MATLAB or Mathematica or whatever problem-solving platform you use. You still may be able to utilize some of the raw data tables that I'm offered. Okay, this is an important point. After your tour, I want you to refresh your memory on what you already understand. Here's what you must already understand to be able to fully utilize this Excel tool. And so I've tried to show a little screenshot of a student or a person trying to make these decisions. What kind of decisions? These are phase decisions, aren't they? Which of these do I have? You have to be good at being able to do that on your own. So remember, on the pressure volume diagram, the vapor dome, you've got to be able to determine what is the phase? What's the phase of my substance, H2O? Over here, I'm a superheated vapor to the right of the dome. Under the dome, I'm a saturated mixture. On the right-hand side of the dome, I'm a saturated vapor. I'm saturated steam vapor. On the left-hand side of the dome, I'm a saturated liquid. In other words, I'm water, but I'm at the boiling point. It's water that's just starting to boil, okay, and starting to transform from a liquid into a vapor, saturated liquid. It's at the boiling point. And then finally, to the left of the dome, you're a compressed liquid. That's where things like tap water, shower water, lake water, compressed liquids, not at the boiling point yet. What's a state? So I want to remind you that a state of any substance is defined by two independent intensive properties. That's a must to understand. And so in the superheated vapor phase, any two of these defines the state. Any two of these properties that you should recognize, that defines the state, any two of those. Now, let's say you're saturated vapor, you're on the right-hand side of the dome. You only need one of these plus the property X, quality, property X. That's a property, okay? So any one of those plus X equals 1.0, that defines the state of saturated vapor. Saturated liquid, same idea, except the property X, quality, is 0.0. All you need is one of these properties. The state is defined when you're a saturated liquid. Now, when you're a saturated mixture, again, any one of those properties pins down the state as long as X is a number between 0 and 1. Okay, so quality is an important property you need to be familiar with. And then finally, the compressed liquid phase to the left of the vapor dome. H2O is considered incompressible, or in other words, constant specific volume. And so the important thing in your textbook, go to your textbook and refresh your memory that for incompressible liquids, particularly H2O, like tap water, the properties, specific volume, enthalpy, internal energy, and entropy depend nearly totally on temperature. And so you're going to go to your temperature table and look up V sub F, H sub F, U sub F, saturated liquid at that temperature, and that gives you the property that you're seeking. And so that's what sets the state for compressed liquids. Okay, and here's a screenshot of your textbook talking about compressed liquids. Very important point. So it's important enough to put a screenshot in for you. But you can make a little note to go back and look in your textbook to refresh your memory on compressed liquid properties. Okay, it's so important. I've invested even another reminder. Where is a compressed liquid? It's over here to the left of the vapor dome. This little sliver here that I've shown in blue, that's a compressed liquid. There's an upcoming test drive, and so we're getting near the end of this video. What I want to show you is what's coming up is I'm going to give you what I've made up is it's like a homework problem, a closed system problem, and I'm going to show you how to solve this problem in Excel. It's an example problem that I'll take you through using the basics of this thermodynamic properties tool, steam tables tool, and how you can solve it all totally in Excel. The video after that, I'm going to show you an open system, steady state, steady flow, if you've gotten that far in your class, okay? Open system, steady state, steady flow, same idea. This would be a steam turbine analysis problem, very similar to work that we do in industry all the time. You have to understand, you have to be up through chapter 6 to understand this problem. Okay. I'm going to do the same thing in English units because English units can be a little tougher than SI. And so let's recap. Gosh, I hope I've kept this. I've tried to go as fast as I could. Apologies if it's going to be more than 30 minutes, but we're just going to have to see how it worked out. Here's your takeaways. I hope that I've showed you how to use this Excel file that I call the Excel Steam Tables tool. To be able to use the tool effectively as an engineering problem solver, you have to understand what's a state and what is a phase. Okay. Recognize, so notice in that tool that I was very careful to label my units. I've got both English units and SI units, so you don't have to convert between units. Both sets of tables are there in that file. And one thing that I think I didn't put on my takeaways that I need to remind you of is that don't forget you're preparing to do well on quizzes and tests in your thermodynamics class. So you don't want to jump to this tool immediately in your homework unless you're very satisfied that you can do this work with pencil and paper, with a paper handout of the STEAM tables. That's what you're going to be doing that in your quizzes and tests. So you've got to be able to do that rather than simply jumping right to an automated STEAM property evaluation tool, and then you're left high and dry on the test. That's not what you want. That's not what I want for you. Do practice pencil and paper with the paper handouts, however you do it. Because there is a pitfall of using the STEAM tables tool too quickly in your own experience to save time on your homework at the expense of training yourself to do well on the quiz and test. So I think that's got it. Let's see, I'm going to quit sharing if I can figure out how to do that. Stop sharing. And I'm going to stop recording and see you in the next video.